Section 9.1 and 9.2. For these sections, make sure your calculator is in degree mode when you're going through any of these calculations. Section 9.1 and 9.2 introduces vectors and scalars. A vector has magnitude and direction, such like you're traveling 10 degrees south at 60 miles per hour. That's the direction with the magnitude. The magnitude is the speed. A scalar only gives the magnitude, meaning it would just give the speed of the car. Vector has components associated with it. So for instance, if I knew I had 7.25 at an angle of 62 degrees, I could write that showing the length as the hypotenuse of the triangle at 7.25. The angle is from the x-axis, again always positive angles, 62 degrees. So 7.25 is the hypotenuse, and you would need to calculate the side measurements. Notice the sides in red. The x side, according to angle 62, is the adjacent side. The y side, again with respect to angle 62, is the opposite side. So side x would use, since I know the hypotenuse, it's going to use adjacent and hypotenuse. Remember, when you're using the trig functions, you always have to have one of the values. So I need the x, which is adjacent, and I have hypotenuse, which is 7.25. So adjacent and hypotenuse is cosine. So I can set this up. The cosine of 62 degrees is equal to the adjacent side over the hypotenuse, or adjacent side over 7.25. Multiplying both sides by 7.25, I get the adjacent side, which is x now, is 7.25 times the cosine of 62. Taking the cosine of 62 degrees is 0.4695. 0.4695 times 7.25 gives me my x distance, which would be 3.403. Side y is the opposite side, and again I have to use a number I know, which is hypotenuse. I don't want to use a number I calculated, even though I do now have the adjacent side. So I'm going to use opposite and hypotenuse. Opposite and hypotenuse is sine, because sine is opposite over hypotenuse. So the sine of 62 degrees is equal to the opposite side over hypotenuse, but the hypotenuse is 7.25. Solving for the opposite side means you multiply both sides by 7.25. So you get the opposite side, which is y now, is 7.25 times the sine of 62 degrees. The sine of 62 degrees is 0.8829. 0.8829 times 7.25 gives me a y distance of 6.48. So I can look at this vector two different ways. I can look at its angular position at 62 degrees with a length of 7.25 as a magnitude, or I can write that same vector as two components. I can say I'm going over 3.4 on the x and up approximately 6.4 on the y. That will express the vector in terms of its x and y components. So if you know the magnitude and the direction, vector A is equal to r times angle theta. So little r would be the magnitude, angle theta is the direction. You can write a general formula, which is the vector components. Ax would equal r times the cosine theta. Ay is equal to r times the sine theta. So magnitude cosine, magnitude sine. And that's exactly what we did over here. We did ax was magnitude cosine, ay was magnitude sine. So magnitude sine is right here, magnitude cosine is right there. So if you know the values of the sides now, let's say I knew ax and side ay, I can go backwards and actually calculate the angle and the hypotenuse. So in order to do that, you'll notice that the hypotenuse is little r. So to calculate the hypotenuse measurement, it's Pythagorean theorem, ax squared plus ay squared square root. And since my ax is adjacent side and ay would be opposite, adjacent and opposite uses tangent. Tangent is opposite side over adjacent. So in this case it would be inverse tangent because I'm looking for the angle. Anytime you're looking for the angle, it's the inverse tangent or whatever function you're looking at. But this is opposite over adjacent, so it's ay over ax. So I can go from magnitude angle and get the components right here, or I can go from components and get magnitude angle. Let's try this example. You're given the magnitude as 600 and the angular position is 28 degrees. Find the vector components. So we know 600 at an angle of 20. I'm looking for AX and AY. I could call this vector anything. I'm just choosing to call it A. So AX and AY. AX is going to be R cosine theta. So it's going to be 600 times the cosine of 28. Cosine of 28 is 0.8829. 0.8829 times 600 gives me AY equal to 529.74, or AX. AY is R times sine theta. So it's going to be 600 times the sine of 28. Sine of 28 is 0.4695 times 600. So for AY, I get 281.70. 28 degrees, right here, 28 degrees. 28 degrees is in quadrant 1. So AX and AY should both be positive, which they are. Again, components AX and AY, positive going this way, positive going that way. Given this vector, the magnitude is 58.3 degrees and the angle is at 125.7. Notice this angle, 125.7, is a quadrant 2 angle. So quadrant 2 angles would have a negative AX component and a positive AY component. Same formulas though. AX is R cosine theta, AY is R sine theta. So if I'm looking at AX, plug in my numbers, 58.3 times cosine of 125.7. Cosine of 125.7 is a negative 0.5835. Negative 0.5835 times 58.3 is equal to negative 34.02. That's my AX component, and that should be negative, and it is. AY is R sine theta, so 58.3 times the sine of 125.7. The sine of 125.7 is 0.812. Again, everything's in degree mode. 0.812 times 58.3 gives me a positive 47.34. Both have the correct signs as an ordered pair and to put it into quadrant 2. So again, negative, positive. Let's try quadrant 3. Find the vector and given the vector, find the components. This time the magnitude is 723. The angle is at 195 degrees. This is not drawn to scale, but it puts me in quadrant 2, or quadrant 3. Quadrant 3 vector has a negative AX and a negative AY. So that's what I should be calculating out. So AX is R cosine theta. Again, same exact formula. So 723 cosine 195. Cosine of 195 is negative 0.9659. Multiply that by 723. I calculate AX to be equal to a negative 698.36. So yes, it is negative. It should be negative. AY R sine theta. So it's going to be 723 times the sine of 195. The sine of 195 is a negative 0.2588. Multiply that by 723. I get AY is equal to a negative 187.13. Both AX and AY are negative. That puts me in quadrant 3. So negative, negative, quadrant 3.